Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. And make sure to stick until the end of the video where I have two bonus problems that are similar to this one which you guys can try to solve. Alright, so I have 2 to the power of x equals 0. And I want to find the value of x. So first off, I'm going to take the log on both sides. So now I have log 2 to the power of x is equal to log 0. Now, if I have something in the form log a to the power of b, I can actually move this variable b, this exponent b, to the front of the logarithm. So this would equal b times log a. So in this case, I have log 2 to the power of x, and I can actually move this exponent x to the front. So this would equal x times log 2 is equal to log 0. Now, I can go ahead and divide both sides by log 2 because I want to isolate x. So then these two cancel out, and I'm left with x is equal to log 0 over log 2. Now, log 2, this is equal to 0.301, and log 0, this is actually undefined. So now I have undefined over 0.301. And this means that our answer is undefined, because you can't divide undefined over 0.301. Undefined is already undefined, meaning log 2 to the power of x equals 0 is undefined. And this actually makes sense because you can't take anything to the power of something and make it equal 0. So that is our answer. So I have 9 to the power of x is equal to 27. And this may seem like a challenging problem because if you notice, if you take, let's say, 9 to the power of 0, right? This is equal to 1. 9 to the power of 1, this is equal to 9. And 9 to the power of 2, this is equal to 81. Meaning, x in this case would be either a fraction or also a decimal, because it can't be a whole number. Alright, so to solve this, it's actually really simple. 9, this is the same thing as 3 to the power of 2. So now if I replace 9 with 3 to the power of 2, I get 3 to the power of 2 to the power of x is equal to 27. Now, 27, this is equal to 3 to the power of 3. So 27, I'm going to replace with 3 to the power of 3. So now I have 3 to the power of 2 to the power of x is equal to 3 to the power of 3. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 3 to the power of 2 to the power of x, that's going to equal 3 to the power of 2 times x. It's equal to 3 to the power of 3. And 3 to the power of 2 times x, that's the same thing as 3 to the power of 2x. So equal to 3 to the power of 3. Now, if you notice, both of these have the same basis. Both of these bases are 3. And if I have something in the form a to the power of a is equal to b to the power of b, so this means that if I have something in the form a to the power of a is equal to a to the power of b, this means that if I have something in the form a to the power of c is equal to b to the power of m, this means that c is equal to m. So in this case, 2x is equal to 3. Now to solve this, simply divide both sides by 2. These two cancel out, and I'm left with x is equal to 3 over 2. Alright, so now to check, Our original equation was 9 to the power of x is equal to 27. Now x is 3 over 2, so I have 9 to the power of 3 over 2 is equal to 27. Now 9 again is the same thing as 3 squared, so I have 3 squared to the power of 3 over 2 is equal to 27. Now I have 3 to the power of 2 times 3 over 2 is equal to 27. These two cancel out, so I'm left with 3 to the power of 3 is equal to 27, and 3 to the power of 3 is 27. So if 27 is equal to 27, and because this is right, our solution is right as well. All right, so I have 6 to the power of x is equal to 12. Now I want to find the value of x. So the first thing I'm going to do is I'm going to take the log on both sides. So now I have log 6 to the power of x is equal to log 12. Now, an important property of logarithms is that if I have something in the form log a to the power of b, I can actually move this exponent of b to the front of the logarithm. So this is equal to b times log a. So log 6 to the power of x, I can actually move this to the front. So I'll have x times log 6 is equal to log 12. And now what I'm going to do is I'm going to divide by log 6 on both sides. So now these two cancel out, and I'll be left with x is equal to log 12 over log 6. So now log 12, this is the same thing as log 6 times 2. Now I have this over log 6. Now if I have something in the form log a times b, this is equal to log a plus log b. So log 6 times 2, that's going to equal log 6 plus log 2. And I have this over log 6. Now this is the same thing as log 6 over log 6 plus log 2 over log 6. So now these two cancel out, and I'm left with x is equal to 1 plus log 2 over log 6. I'm going to again change to log 2 times 3. Now I have x is equal to 1 plus log 2 over log 2 plus log 3. Now log 2, this is equal to 0.301. And log 3, this is equal to 0.4771. So now I have x is equal to 1 plus 0.301 over 0.301 plus 0.4771. So now I have x is equal to 1 plus 0.301 over 0.7781. Now I have x is equal to 1 plus 0.3868. So x is equal to 1.3868. Alright, so in this video, I'm going to solve the equation 3 to the power of x plus 3 to the power of x is equal to 12. So, my only variable in this equation is x, so that's the variable I'm going to be solving for. And now for my solution. So I have 3 to the power of x plus 3 to the power of x is equal to 12. And what I'm first going to do is factor out 3 to the power of x. So I get 3 to the power of x times 1 plus 1 is equal to 12. Now 1 plus 1 is 2, so I get 3 to the power of x times 2 is equal to 12. So from here, we want to isolate x. And to do that, we have to get rid of this times 2 by dividing both sides by 2. So now these two cancel out. And I'm left with 3 to the power of x is equal to 12 divided by 2, which is 6. So now I have basically another equation from this much larger equation. So this is much more simplified. I have 3 to the power of x is equal to 6. So to solve this, well, we know that x is going to be a decimal because 3 to the power of 1 is 3 and 3 to the power of 2 is 9. So x is going to be somewhere in between 1 and 2. So we want to find the exact value of x. So how are we going to do that? Well, I'm going to first start by taking the log on both sides. So I get log 3 to the power of x is equal to log 6. And from here, if I have something in the form log a to the power of b, I can move this exponent b to the front. So this turns into b times log a. So I have log 3 to the power of x, and I can move x to the front. So I get x times log 3 is equal to log 6. Now I'm going to divide both sides by log 3, because again, we want to isolate x. So by doing this, these two cancel out, and I get x is equal to log 6 over log 3. Now, what I'm going to do is rewrite log 6 as log of 3 times 2. So I have log 3 times 2 over log 3. And if I have something in the form log of a times b, this is equal to log a plus log b. So log of 3 times 2 is equal to log of 3 plus log of 2. And I have this over log of 3. So now this turns into log of 3 over log 3 plus log of 2 over log 3. And now these two cancel out, so I get x is equal to 1 plus log of 2 over log of 3. Now, log of 2 is equal to 0.301, and log of 3 is equal to 0.4771. So I get x is equal to 1 plus 0.301 over 0.4771. And 0.301 over 0.4771 is 0.6309. So I have x is equal to 1 plus 0.6309, which is equal to 1.6309. So this is my solution.